All right, folks, we're going to be working on the second set of exercises in Chapter 3. We're going to start with problem number 8. This is the paint calculator assignment. And I'm going to begin by very carefully reading the assignment description. The devil is in the details, or the solution is in the details, and it's all in how you read it. And that's really an important skill when you start working with actual clients or in a workplace and you're asked to do specific programming tasks to really clearly understand what's being asked. And I know that some of you are struggling with getting the meaning out of this, especially since we got some new concepts going on, but we're going to show you how it's done here. All right, so it says, assume that a gallon of paint covers about 350 square feet of wall space. Create an application with a main method that prompts the user for the length, width, and height. All right, that seems pretty easy. We've done that stuff before. Pass these three values to a method that does the following. All right, so it's got a detail. Calculates the wall area for the room. Makes sense. Passes that calculated wall area to another method that calculates and returns the number of gallons. Displays the number of gallons needed, computes the price, it's $32 a gallon, assuming the painter can buy any fraction of a gallon of paint at the same price as a whole gallon. Because this is one of those things where clearly he had it in this detail. It's like, well, I can't go to the paint store and buy 1.35 gallons of paint, right? But we're going to assume that's the case. Okay, that's what they're telling you here. All right, and then finally it's going to return the price to the main method. So they're giving you a roadmap of what you need to do. All right, and then finally it says the main method displays the final price, and they give you an example of what the output might be. So the first thing you have to figure out here is we have a lot of information, we have a roadmap for how to build the application, but we need to figure out how to do the math, right? They're asking you to calculate the wall area for a room. So the discussion can begin right there. How do you determine the area of one wall? Length times height, all right, for one wall. All right, assuming the room is rectangular, you could multiply that by 2 and you got the two opposite walls. And then at the same point in time, you can do the same with the other two walls. Yeah, if it's square, but that's not usually the case. Then I also get students that'll go in and argue, well, what about the ceiling? Right? And you know what I answer them? It's like, well, if you want to calculate the ceiling, throw it in. I don't care. That's your choice. But it does say very explicitly, it says wall area. So I read that as walls. Okay? So if we were to figure out the calculations for that, and this is what you guys should be doing. You should be working out your math first. You should be figuring out that process before you start to write code. So I'm going to bring my little text editor over here, just a little scratch pad basically. And so we got a room with 4 sides, and we assume that it's rectangular and that opposing, or not adjacent, opposing, opposite walls have the same dimensions. So we would have basically length times height, and then we were going to take all of that, right, times 2. That covers 2 of the walls, right? So now really, you could actually say length 1 times height 1. No, actually the height's going to be the same for everything, isn't it? All right, so that's one calculation. The other one would be the second length, so I could do length 2 times the height times 2, right? And really, if I wanted, I could even simplify it further Now, I know that I don't need the parentheses and it would still calculate right, but I'm just doing it to basically show you that sets of walls, but also to make sure that it works out correctly. So really this is the calculation already. And if you really look at the pieces of information, we're going to ask for length 1. We're going to ask for length 2. And ask for height. So we're going to have 3 prompts. Right. Then we're going to do a calculation and we're going to store it somewhere. And that thing that we're going to store it in is going to be maybe called wall area or something to that effect. Now once we've determined the wall area, then we have to do some additional calculation, right?
Yeah, we got to divide by what the estimate of gallon of coverage is, 350 square feet.
And that's going to give us what, Sean?
The approximate number of gallons that we'll need to cover the entire area.
So you get that? Whatever the wall area is, divided by 350. 350 is what 1 can of paint will cover. That'll give us the number of gallons. Once we have the number of gallons, we want to know the price, right? The total cost. And what was the price per gallon?
32.
32. Now keep in mind, I'm just pseudocoding here. But I'm also pseudocoding in a fashion that's getting me really close to where the code's going to be. So I have my roadmap already. Now they're asking us to do a bunch of other stuff, though, like how we're structuring the application. So why don't we go ahead and get started with that process? All right, I'm going to be using Eclipse, and I'm going to close all my previous work that's open here. Probably the same stuff I left open last week. I'm going to go ahead and I'm going to create a new Java project. And what are we going to call this? Chapter 3, Exercise 8. Is that correct? Yeah, that's what it is. All right. And then inside that project here, we have our source folder. That's where the source code goes. We're going to do a new class. And we are going to name it. What are we going to name it? Does it tell us? Paint Calculator. It works. And we will put in a main method. All right, so we have the basics for a program here. Now we know we're going to ask for input from the user, right? So why don't we just go ahead and create our scanner right away. I'm just going to stick with calling it input. It's kind of my habit. So we're going to do new scanner. What did I put in the parentheses? Oops. Not inheritance. Okay. Now I'm just putting it in there, and the reason I'm putting it in there is to leverage the built-in tools that Eclipse has, because I know it's going to throw an error because I don't have the import, but it's easier to type that in, throw the error, and then click the fix than it is to go to a different program and look it up if you don't remember. So, trying to be clever, it doesn't always work. All right, let's read the instructions again. All right, create an application with the main method that prompts the user for length, width, and height of a rectangular room. Let's just do that part of it. So we're going to need three variables, right? Length 1, length 2, and height. All right. So watch what I'm going to do here. I'm going to do int height equals what? Oh, I want to prompt them first, don't I? Let's do a prompt. System What's the command I need to type in? Okay. We're going to basically be repeating that process a few times, right? A couple more times.
I decided that rooms are always perfectly perfect integers. That's not a problem.
Yeah, that's a good point.
Like, 17 and a half feet.
All right, you convinced me.
But
Let's do double. That's fine. Let's do double.
it's not gonna be double. It's all good.
You know how it is? I'm trying to make it as easy as possible.
I know, but I toyed with that for a while and then,
That I think it's a perfectly valid argument. So let's go ahead and just make those changes. And of course, I need to change all the things that correspond. And then for the first one, we're asking for height, right? So we got height, and then let's do length 1. And the way we're going to prompt is enter wall 1 length. And I'm going to say adjacent wall length. Maybe I'm going to say wall 1, right? So enter the length of the wall, enter the length of the adjacent wall, right? And that covers the whole room. And this one obviously is going to need to change to be that. All right, we got a scanner. We set up 3 doubles. We prompted and we grabbed values. Now, from our roadmap, or our little primitive pseudocode here, we have some information that we can certainly pull in. But what I'm looking for is the fact that we've got things that are going to be calculated that need to have places to go. So we need wall area, number of gallons, and total cost. Now, the typical programming approach is to put all those things at the top, and you can. In fact, you might want to begin that way just because it's simpler. You don't have to do that, though. There's no obligation to do it in that order. So what we might choose to do is actually, like the wall area, or you can just call it area for that matter, we can just create right here on the fly. So we can just say double wall area equals this handy pseudocode that's almost got the perfect syntax here. Right? And then we need to determine the number of gallons. Once again, we're going to need number of gallons to also be a double. We have a semicolon at the end. And we also need to calculate the total cost. Now, I know the program's asking us to do other things. Okay, so I'm not losing that in my head, but now the stuff's in here in a format that works. And don't worry, I will adjust it. I did copy that, but I guess. What's the price per gallon? 32. Okay, and those are hard-coded. Now, one approach, of course, would be that I could actually set these up as constants. And some programmers will argue that's better practice. My thought here is it's very simplistic, so we don't really need to go to all that trouble. All right, let's read the instructions because we have all our logic in place. Now it's just a matter of structuring it appropriately. I can just find my book. There we go. All right. So once we have these three values, length, width, and height, we are going to pass them to a method that does the following. All right. So we're not going to just do that right here because the point is that we've grabbed the values and now we're going to send them off somewhere to do some calculations. So really, all this stuff I just added here, right now I'm going to comment out. I just have them handily placed so that I can grab the math and put it where I need. But it's going to tell us that we need to pass those three values. So we're going to have to write a method that calculates for us. It tells us to pass those three values to a method. So we're going to need to create some method. Let's call it calculate or calculate cost, right? Okay. Calculates the wall area for a room, passes it to another method, so we're going to need to create two methods. Displays the number needed. Hey, you know what would be really good to do? So how about, I'm going to paste it in here first because I'm going to have to clean it up. And even though it might seem like a really dumb way to proceed, I'm going to paste this in. As a series of steps because then I don't have to go back and forth and look. All right. We're going to need two methods. Before we create the methods, I'm actually going to create a call to a method. All right. I'm going to call it calculate. And I know I'm not doing this in proper fashion quite yet. Calculate paint. Calculate area. Want to call it that? All right. All right. And it says that we need to pass values to it, right? So what are we going to pass? Yeah, so we're going to do, order is important here. All right. So I'm going to pass in height, length 1, and length 2. That's going to be the method call. And notice this is going to indicate there's no method called calculate area. So thank you, Eclipse. You can do that for me. You guys catch that? So you're wondering, why did you do that first and not do the other thing first? Well, all right, let me just undo that. So see, I created a call to a method that doesn't exist. Eclipse recognizes it doesn't exist. I hover. Then I click the link. It says create method. And what it does is it sets up a structure for me. Private, static, void, calculate area, receives 3 doubles, it recognizes that they're doubles, and we're all set to do our work. So now, hey, that math that I was kind of doing as a throwaway, remember that? You'll remember now. We're just going to drop it right in there. So we're going to grab those 3 values from the user. We're going to send those 3 values to a method that's going to do the calculation. What else is that going to do? It calculates the wall area for the room. Done. Gone. Delete. Then it's going to pass that calculated wall area to another method that calculates and returns the number of gallons needed. So what about us calling it, and notice where I'm doing this now, calculate gallons, parentheses. How do I calculate the number of gallons? What do I need to send to it? It said passes the calculated wall area. So what am I going to put in there? Wall area. And no, we're not doing math there. The point is, we could do all the math just like I did it in the program would work. The point is to see how methods can pass stuff and how you can chain things. All right. So once again, it's recognizing that we don't have that method, so I'm going to let it create the method. There it is. It recognizes that wall area is a double, so it sends it down that way. And then that particular method passes and returns the number of gallons. Notice the keyword returns. So not only is it going to calculate, we already have the calculation, right?
What do you have the return keyword?
I don't have it yet.
Ah, okay.
This is the instructions here, Sean. And it says returns the number of gallons of paint needed. All right. So that's what I'm doing next here. So I'm just going to put in a return statement. What am I returning? Num of gallons, semicolon. Okay, so I got another thing I can cross off my list here. And the list gets shorter. And really, we already used this equation, so it gets even shorter. All right. Now, this is noticing that if you're calling a method that returns a value, wherever you're calling it from has to have some place to put the value that's returning. So this is going to necessitate a variable from where it's being called. So we're not just going to call that method, we need somewhere to put the value. What's it returning? A double. And why don't we just call it gallons? Yeah, oh, there you go. Gallons needed. Descriptive. I like it. All right. So it's returning the number of gallons needed. So now why is it underlining? Yeah, it says change return type of calculate gallons to double. What is it talking about? The void. See how it's highlighting it? When a method is returning a value, the void keyword has to be changed to match the data type you're returning. So void, when it's in place, indicates nothing's being returned. But if it is returning something, you have to tell it what data type it is. Okay? All right. So the next thing it's supposed to do is display the number of gallons needed. Because now we know, right? So we can do a system out, print line. In fact, let's do it like this. Gallons needed. All right, another step eliminated. It also will compute the price based on a paint price of $32 a gallon assuming the painter can buy any fraction of a gallon. We know that not to be the case, but maybe, Christian, you can set us up with a deal. Plugging Sherwin-Williams there, right? Are you the Sherman? Okay, sorry. Now I associate you with HVAC. So now, obviously, we're going to need to change the name of this because we used a different variable name, right? Gallons needed. All right, so there's another part done. Another part done. See how our list is getting really short? And then finally, it's going to return the price to the main method. All right, so now we're going to put in a return statement here. What are we returning? Total price. Notice once again we're getting the same problem. What's the data type of total price? All right. Change that. Now we're going to run into a different problem. It's returning the total price. What is it returning it to? Yeah, we need to, well, we are calling the method. We can put it anywhere, so where do you suggest I put it, Joe?
I guess I declared the variable total price and then above there. Oh, well, yeah, I guess you don't really need to. You could just do it where it says calculate area. When you call the method,
Right.
just say cost equals calculate area. I didn't call it calculate area, so that seems strange to me.
Well,
Just say compute or calculate.
Yeah, you know, the naming is kind of arbitrary. Sometimes you name things just so you can build it, and then you realize a better name would be.
So I guess you could just declare it right there.
Yeah, and that's the pattern I would use. I would declare the variable. We know that calculate area is going to return a value. Has to have somewhere to go. And that.
Another question though.
Mm-hmm.
So you're calling this calculate area, and you're sending it height, length 1, length 2. Do those names there have to be different than the
Excellent question. Now you notice what Eclipse did.
or, you know, like, I don't know. I'm not
Okay,
sure.
your question is spot on, and I was hoping to talk about it. The question really is, we are sending variables in, and where we're passing them to, Eclipse, our IDE, decided that it's okay to use the same name, because the truth is, it works. Okay, but the better practice is really to rename them. So for example, I might do like something like that. All right.
So there's not, I mean, it's going into that spot, but it's not really the same thing.
No,
Height
it's
and
not.
height are not the same. Height in the main method is different than what height might end up by the time it's done with calculate area method.
That's correct. You know, and in fact, if you want me to follow through with the example, I might just change it to H, and then L1, L2, and then I would also have to change all of these.
Well, I had something different, then all of a sudden, I went like, instead of length, width, and height, I went long, wide, and whatever, and then found out I can't use long.
Oh yeah, because it's a keyword. Long is a keyword.
It's a great idea, so I got kind of poo-pooed on the long.
All right, and Joan, you're right, this is considered better practice, but it also is showing you that the stuff that's in one method doesn't really affect the stuff that's in the other method. The fact that Eclipse does that by default indicates that it's pretty safe to do. It's just not considered, no, it's not. All right, so let's finish off here. We're gonna do a system out print line, and we're just gonna, let's see, we could be very verbose here, and that's probably a good idea. Let's just think about this for a second. That's not where we need to do that, is it? Where would we want to do that output statement? Where are we calculating the area? Then it calculates the area. So many gallons are needed to paint the room. I could even return the price down here, but really all we're going to return here is and I know, keep in mind there's more than one right way to do this. Still make it work. In terms of having it execute the methods and the returns that it's asking for, this is essentially correct. Where I do the output statements, how I phrase the output, all that stuff, that's very subjective. So I'm going to go ahead and save this. I think I'm ready to run it. And by virtue of the fact that we pretty much have an on-the-fly debugger here that's showing us errors even as we're typing in the code, chances are it will compile just fine because we don't have any red underlines. We do have some yellow things that pertain to some non-critical areas. It says resource leak, input is never closed. And basically it just refers to how memory is being handled. And when we deal with really large applications, that really becomes an issue. But for what we're doing, no worries. Okay, program will work just fine. So let's go ahead and try to give it a run and cross our fingers and hope it works.
So in Eclipse, if you just compile, when you don't have a main in a certain part, you just compile it, or you just hit the same run button and then it compiles it and then just sits there, or like...
Yeah, that's a good question, because when you start creating just classes, yeah, you hit basically that button and it does a build, is what it's called, a build. So the build is the process of taking it, it goes through and debugs, it compiles it if there's no errors, and then it generates a build file, which is basically the executable. It's also possible to actually do the build directly from the menus. So, and those are done a number of different ways. They had another question, Cindy Lou?
Well, and to Joan's question, I had the same question too, so I Googled it, and I thought I read that pretty much when you save it, it's already compiled. You don't have to run it.
I'm not sure that that's necessarily the case.
Because I can save it without a semicolon or something, right?
Yeah, you can save it. Yeah, you can save it in an incorrect state.
Yeah, it should like not then compile, but I just didn't know what that was.
Well,
And, I had that happen in the do it, and I always got, when I went to click the run button, I'd get like the ant build. And
Yeah, that's because there's errors going on.
But I think that was because I saved it somewhere and then I tried to rename it.
Some data in. All right, so we have it running down here at the bottom, and I'm going to enter a height. What's a reasonable height? 8 feet. All right, that's pretty typical. What's the wall length? Let's do easy numbers. How about 10? 20. Now, before I hit enter, guess what I'm going to do? I'm going to calculate it to make sure I'm getting the right numbers. So if I have 8 times 10 times 2, that's 160. And if the other one's 20, it should be double that. It should be plus 320, so it should be 480, right?
I got 1380.
Divide by 350. Oh yeah, you're right, because 480 would have to be doubled, right?
No, I didn't. I didn't set numbers at all.
Okay, I had 480. We divide by 350 for the number of gallons, so I would need 1.37. So hypothetically, when I hit the button here, it should give me that answer. And there it is. So it's good to do some math beforehand to make sure that the output you're getting is correct. Okay, can you tell me what those figures are?
Your 15 by 20 foot room with 10 foot ceilings.
Okay, so the height is 10, one is 15, and what was the other one? 20.
That's how I
Okay, wall area of 702 gallons are needed. Total cost is $64. Does that look right? Yay! All right, so in this example, we haven't touched objects and classes yet. This is still working with methods. But what this is demonstrating is what we call chaining, because we're calling one method, and then that method calls another method. And you can do that. All right, I'm going to take a pause here, and we're going to come back and work on another exercise, and we're going to take a break here in class for a little bit, okay? All right, we're going to move on to the next exercise, which is exercise number 11. And I'm just going to begin by making a new Java project in chapter 3, exercise 11, same pattern we've been using. It's good to be consistent that way, if you can. And then I'm going to right-click on the source folder and add a new class file. Now they are asking us to name this sandwich. Now, in terms of this course, this is the first time we're creating a class file that does not have an executable component. Okay, so I'm not going to check the box that says create the main method. We'll leave that blank. All right, so we have this particular thing here. Now, I don't like the fact that it packaged it, so I'm removing that declaration. It's not a problem. Okay. The reason I don't want to do that is we're not building like a big, robust project simplicity. It's actually to our advantage here.
Mine looks like it says default package and all mine. Is that a problem?
No. The default is what's implied if it's not present. All right, so we're creating the public class, and let's read the instructions actually before I go too far with this.
Data files include string for the main ingredient,
Okay,
string for bread type, double for price.
okay. Yeah, but I'm going to fall into this trap here again. I'm going to copy paste to get all the artifacts. So data fields, Joan's going to read it to me. So data fields, we do how?
String for the main ingredient,
We call it main ingredients.
and then a string for the bread type,
A little typo here. Okay, go ahead.
double
And a
price.
Yeah, it doesn't say that here.
So,
Because we're creating a class, which is going to be the blueprint. We're just setting up a structure. We're not getting any values here.
okay, not
All
in
right.
here.
Not in here. Now, typically when we include methods to get and set, we would do something of this nature. We would do public,
Void.
yeah, right, because we're not returning anything. And then we're going to do, let's say we do our gets first. We would do get main ingredient. And if we're getting it, we're not requiring any values to come in. And all a get does is return a value, so it would return main ingredient. All right. Now, it's not liking this. Oh yeah, we have to put in the return type. I forgot to do that. Because it is returning something. We were thinking with the other one. All right, but let me show you a little trick here that Eclipse does. And I just have to remember where the heck they put it in this program. Do-do-do-do-do. Where the heck do they put it? I'm sure the people can hear it in the video. Make sure that's recorded. So instead of going through the painstaking process of creating the getters and setters, you can literally right-click on the data field, go to the source menu, same one that you see up on the menu bar above, and see this little option right here? Generate getters and setters. And it does it for you. Now I'm going to do an undo here, and the reason I'm doing that is because I've already set some of this and I don't want it to conflict. So I'm going to just go ahead and do that again. And actually, see how it gives me the option I can do all of them? And it creates all of them. Now the way that it's structuring it though, I'm not really liking that a lot, so I'm going to actually move the data types back up to the top because I like to have them all together. And then my habit is to leave spaces between things. But it went through and it automatically created the whole structure. Now some people will say it's what, Hayden? It's cheating? Or is it just leveraging the tools that we have?
If we can use it, it's not cheating.
You can use it, so it's not cheating. Now the one thing that they do here that's a little bit different is they're throwing in the keyword this, and we haven't even really talked about it in this language yet. So that's really kind of optional, but what this does is it's self-referring. You should just leave it in there. Will it work without? Yes. Okay, so let's just leave that in. So we have our getters and our setters, and I don't think we have anything left to do here, do we? No, we have our 3 data fields, we have getters and setters for each. We're fine. Now, from a conceptual standpoint, this is identical to what we were talking about in the lecture portion, that each data field has a way to have it set data and return data. All right, so our job with this file is done. So I'm saving it. All right, so now I'm going to go ahead. Well, we still got this little bit underlined here. The declared package does not match, and I'm not going to use that. I'm going to use the default package. So if you guys have that same error, you can do what I just did. All right, so now it's asking us to create a second file. Joan, do you want to read that for us?
Yeah, one second. I'm gonna So our test sandwich.
Yep, test sandwich.
This sandwich is ours so nice and tasty.
So we can do that a number of different ways. Generally speaking, simpler is better. All right, so what we're going to do here is first we're going to create the object. So the way that we're going to create the object is by just simply saying sandwich. We treat it like a data type. Abstract data type. And what are we going to call it?
I call it first sandwich.
First sandwich?
It's the first sandwich that I've created.
Okay, fine. We'll call it first sandwich. And we're going to create a new sandwich. Oh, we forgot the parens. That's our default constructor. Now, notice how it's underlying. Oh, I know why. All right, we got to take care of this. The fact that the default package. All right. Because what happens is if they're not in the same package, the files don't see each other.
Oh, the first sandwich versus the sandwich.
All right. All right. So now we created the sandwich, and then we're just going to go through and we're going to add to the data fields one by one. So the first sandwich, we will set the main ingredient. Now you see what Eclipse is doing? It went out, it located the sandwich file, right? Sandwich class, and I just started typing set, and it went into that file and pulled down the methods that are available that are sets, just by typing those 3 letters. So which one do I want? I want to set, let's set the bread type. What kind of bread are we going to have? You got to go with the rye. Oh, okay, how about this? Marble rye. Yeah, there you go. And then we also want to do the same thing with all the other stuff. And this time we're going to set the main ingredient. What are we going to put on that sandwich? How about corned beef? I haven't had corned beef in a while. And once again, we'll do the same procedure. What was the last one? You know what? I don't even have to remember. Because all I just do is start typing set and it'll find it for me. And the price for that is $3.99. No, a good corned beef sandwich is probably like that much.
Yeah, probably.
All right. So now we created an object, first sandwich. We'd set its bread type, main ingredient, and price. And now we're going to make sure that it grabbed those values by getting them. So we can actually do that in one fell swoop in an output statement. And that's probably the simplest way to do it. All right, so what I'm going to do here is I'm going to get the main ingredient first, right? Because you usually say, I got a corned beef on rye, right? That's how you do it. So I'm going to do first sandwich dot get main ingredient. So that's going to pull back the main ingredient. And I'm going to get rid of this little sidebar area here. And I'm going to drop to the next line. I'm going to get the bread type. How much does it cost? Well, I don't know. Let's see what First Sandwich says about it. And anything else we need to add, or are we good? Yeah, that's a good point. Maybe a $sign right here. And if you want to do the currency formatting, go for it. But this is really enough. So we're creating the object. We're doing 3 sets to set the values. And then we're doing outputs, which have the 3 gets right in there. So these will go to the object and pull the value back. The only job of the sandwich class is to provide the blueprint for what First Sandwich is. First Sandwich is an entity unto itself. It is not the sandwich file. The sandwich file is what shows us how to put that together. That's all it does. So now when I run this, and I think this is answering the question from before, when I hit the play button here, it's going to save. It's going to compile all the files that are attached to this, including the sandwich class.
I was wanting to do just the sandwich class without the test sandwich. You know, like you get done with part of it, and you're like, oh, look, I'm not okay. I have any mistakes, you know.
Right. Well, and that's what you do very often in coding is you might create classes, and then you'll write silly little programs like this just to make sure it works. You know. And that's why a lot of the little applications that we'll create relative to class files will be called test. And that's really a process that you guys are going to learn as you go along. And you can see that it worked. You ordered corned beef on Marble Rye, which cost $9.99. Worked great. All right. So that was exercise 11. I don't know if we have time to do 12, but maybe we can get started on it. Oh, this one's a lot of fun. We're going to try to get to the point where we get most of 12 done, or at least part of 12. You can see that 12's actually got 3 different parts. And the concepts here are pretty important ones, so I at least want to touch upon how they work. Like we did in the last problem, we're going to need to create a class file to start. All right, so why don't we get busy doing that? Let's go ahead and make a new project. And we're going to call it Chapter 3, Exercise 12. We'll make a new class file. And we're going to call that Student. Does not need a main method. All right. Next part says, has fields for ID number, number of credit hours earned, and number of points earned. So, and they give us an example here. For example, many schools compute grade point averages based on a scale of 4, so a 3 credit hour class which a student earns an A is worth 12 points. Great. You guys got that memorized? Very good. So let's create some privates. We got a private. What was it? Student ID?
ID.
And that's a string or a number? Okay, let's do an int. And we're calling it what? Student ID. And then we'll do a private int credit hours. Private int. Thanks, Joan. You're making this much easier. All right, now, do we need any more? ID number, number of credit hours earned,
The last
and number of
sentence,
points.
it also has a field for grade point average.
Okay, so many school. Ah, but here's where the challenge comes in. Can we calculate that?
I just divided later on.
So we don't necessarily use a variable, we just calculate it.
Well,
I did, just grade point, return of points divided by non-credit hours, to get the grade point, but I declared it, but I don't know if I need to,
and
published double G grade point, I get the return of points divided by non-credit hours, and I gave you the math came out later on.
right, and Bill's totally on the right track here, because what we learned in the first example was that we create getters and setters for everything. So it's kind of like a generic structure. But it's also possible to write methods that do computations and output right inside the class. And sometimes you do that because it's the easiest way to do things. And that way, when you actually instantiate the object and utilize it, you don't have to write code to do those things. It's already built in. And that's kind of the beauty of the encapsulation. So let's see. We have the 3 data fields. We need to have getters and setters for all of them. So let's just go ahead and do that right away. So I'm just going to click on one of them. And what folder was it in? Source, getters and setters. What was that error message again? There we go. I need to highlight it is what it is. So all of them are going to have sets and gets. You notice you got the little check boxes here. If you don't need a get or you don't need a set, you can always uncheck it. All right. So let's go ahead and do that. Yeah. Now, and I put these way at the bottom again, and I'm not a fan of that, so I like them up here at the top. We got all our gets and our sets, and it's going to give us a little bit more instruction here. It also includes method to assign values to all fields, and a student also has a field for a grade point average, and include a method to compute the grade point average by dividing the points by the credit hours earned. All right, that's kind of a lot of information in a very short amount of words. You know, so you got to be really careful on how you do the interpretation. So, does it have us add a constructor at any point? Okay, that's the last step. Okay. Very, very last step. Okay, so what method do we need to include? Include methods to assign values to all fields. We did that. Didn't we? Yes. How do we assign values to all fields? With the sets. We set the values. Yeah, that's the terminology part that you want to. All right, so we know we're already good. Okay, our job for part A is actually done, right?
Well, if there's a method to compute the grade point average.
Oh, okay. So let's do that. Yes. We do need to have a method. Okay, so if we're going to compute it, is it going to return something?
Oh, because it's not a book value, so you can't just set it inside do the computation inside the set because it's actually a new value.
Yeah, it's better you could do it inside the set if you wanted to. But that's not where I would do it.
Wouldn't that like aesthetically make no sense?
No, no, it could make perfect sense to do it that way. It's all in the design. So for example, if you were to set a value, let's say, this is an off the wall kind of example. Let's say, how many miles did you run today? Right? But you're entering feet, and then the calculation converts it to miles and then stores it. See what and that can be part of the set. This is a different type of thing. So what did it want us to do? Calculate the grade point average?
Yeah.
Oh, but it says it also has a field for grade point average. All right, so So that's something that we need to actually create. This is the question you should be asking yourself. So is that something I should throw in up here?
I say yes.
Yeah. Well, actually, you could do it inside the method. Yeah, that's a very valid point. Now, if I'm reading this literally, and this is where the challenge comes in this book, but you shouldn't feel bad if you misread it because you can still make it work. All right. It says, a student has a field for grade point average. Include a method to compute the grade point average by dividing.
Oh, but it says the grade point average field.
Okay. Also has a field for grade point average. So
Computing the grade point average field.
The points and credit hours are already declared for the class, right?
all right. Can we agree here? We have to do some math.
Yes.
Okay. Now I'm going to put in here.
Like, are the private ones accessible inside the method that we're creating here without passing them in? The number of points and credit hours private variable?
Well, okay. Think about how this is going to work. When we create an instance of this object, whatever values we set follow the object.
Okay.
So then in order to access any part of it, either via set or get, that object's going to sit independent of this class file.
Right, because this is its build.
Yeah, the blueprint. Yeah, it's a blueprint, basically. So, I'm kind of getting ahead of myself here, but what I was hoping to do is just get to the math part of it. How do we determine the grade points?
Points by
Is that what I called it? Num of points? Num of points by what? Hours? And we called it credit hours. Forget from 1 second to the next what I called something. It's not very helpful. It also has a little bit of information in there. Write methods to display the values in each student field. So here's one that's going to get the grade point. What about displaying stuff?
So I just had a bunch of methods down there, public void, show student ID, and system of that in there, and when you get to the application piece, you call it from there.
Okay, and my mind thinks exactly the same way. And show is really a good word to use here because we're just showing it, you know. So show student ID. This is once again, I'm forgetting what I called everything.
Are we going to have to create something to store the get grade point in the main method? Because it's just returning the somewhere?
Let's get to that. And my point on that one's going to be, we could store it internally, but it would be a thing that also changes, so it doesn't necessarily need to be stored. Let's show the practicality of it in use, and then you'll see what I mean. All right, I'm forgetting my curlies here. All right, so we're going to show that. How are we going to do that? Is that not the way we're going to do it? And what we're going to put in there? How about we just say student ID, something like that? Do I really need anything else? Yep. So I'm just going to replicate this a couple more times. Of course, we're going to change these. So we're going to show student ID. What are the other fields?
Credit hours. hours? How many points?
And this one, oh, did I put that in the wrong spot? I sure did. You notice I'm collapsed there too, so this stuff needs to be moved. I did have it looking nice, and now I messed it all up. And I know that these are underlining, and that's because I have redundant names. And the last one is show number of points. What should the text here be? Grade points. And this should be credit hours. Okay, so we have a way to get the grade point. That does math. We can show each one of those. We got some output. We're throwing out some variables. Anything else we need to put in there?
When we're writing the class, it doesn't matter which order we have these in class.
Nope, they can be in any order. Any of the stuff can be anywhere in there, it'll still work. As long as it's nested correctly.
All of those have to go in the class, right?
That's right. This is just setting up the blueprint. And now guess what we're going to do? We're going to do a test. So we're going to do, actually this is a show student. So write a class named show student that instantiates the student object from the class you created and assigns values to its field, compute the student grade point average, and display all the values. You guys ready? Why does it want us to compute it again? Well, what it's really asking us to do is to call upon the method in the class, and actually, once the object is created, the method in the object that computes it for us. So that the syntax in the main body of the program is really simple. So we're going to add another class file. This one is going to have a main method. We do want it to execute, and we are going to call it, what do they call it? Show student? Show student. All right. Joan, read me the instructions.
Write a class named show students that instantiates a student object from the class you created and assign values to its fields.
All right, so we're going to do pupil dot set ID. What's the ID number going to be? 1, 2, 3, 4. That works for me. And then we're going to do pupil dot set credit hours. Or let's do points first. How many points? 47. I don't know why, just because. Let's see, what's the next thing we have to set? The credit hours. How many credit hours? Say 15. I'm just grabbing numbers at random that seem like they would work. All right. And then what we want to do is we want to show all those values. So we can do show, let's zoom in the same order, ID, show credit hours, And show points. I did those backwards, didn't I? And if you want to kind of see a little separation of logic here, you can do that. And then finally, we want to show the grade point average, right? So what we're going to do here, I'm going to do a little system out print line, because that grade point average didn't have any system out in it. So we're going to say GPA equals, I'm trying to keep it brief, what's it going to equal? Yeah, well, it's system hour in this case. System out print line. Now I'm just getting this like thought in my head, and I'll tell you what my thought is. When we were in the student class, it's going to do some math, right? Mm-hmm. Are we missing something? What do we need to be able to do the math is really the question. Numbers. Yeah. Thank you very much. All right. I'm just gonna proceed down this path, and you guys can try to follow me. Let's see if you, because I will tend to lead you astray. All right. So how do I calculate the grade point average then? What do we call that? Get. I forget what I called it. The math. This is the math part. Get grade point. That could have been named a little better, I think. And then parentheses. Is there anything else I need to do aside from that semicolon there? It seems too simple, doesn't it? Say that again. No, it's like my first thought in my head is like, don't we need to send it a value? I'm like, no. The object already has all the values, right? Because we're setting all these values here, and then if you look at this file, the math is just using the values that are already in the object. So all we have to do is call it by name, and there it is. Isn't that beautiful? Yeah, that's absolutely the way it is, right? You say it, and it is. No, you could, absolutely. If you wanted to do a scanner, okay, what's your student ID number? What are your grade point? Yeah, absolutely. Oh, no. If anything, that's extra work, so you did extra work for no extra points. No, but yeah, I mean, we're doing like kind of simplistic examples, but absolutely you could do interactions like that, back and forth. This is really enough to test it, so let's try to do that. Let's test it. All right, so grade points 47, credit hours 15, GPA 3.0. Does that sound right? That is correct. You guys all have a 3.0 or better, right? Now there is one more part to this problem, but we are really pushing into the next class a little bit too far. So I'm gonna, sorry guys, once again. Now, I just want to say with this last part, just to give you guys a roadmap of where you're going, I have a solved version now. It's with different names for all the items, but I'm just going to flash it up on screen here really quick. So this would be show student 2, and all that this is doing is it's allowing us to just run these particular functions, assuming that the student file already has built into it this constructor. So in other words, when we do student pupil equals new student, even though we're passing in an empty constructor, that default constructor is what it's called, will populate those values for us.
Is that a practice that like we should get into, at least throwing in like X's or some default value?
Frankly, my favorite answer is it depends. It depends on the situation. If the situation calls for it, yes. Like,
Or just for like testing, it'd be easy testing it like that.
yeah, that's one of the reasons you do it. But if you think about application development in terms of like what you might eventually do with the data, which in like a formal application usually means it's being populated to a database, sometimes you need to put in default values just so you don't mess up the database, because the database will say null is not allowed. You can't have a null GPA, throw in a 0 at least, that kind of thing. All right, so we're going to cap it here, folks. Have a good week, and we'll see you next week. Oh, fair warning.